Hey, we've got a little Swedish flag here. Maybe most people don't know, Hopsworks are a Swedish company, and we're fully European owned. We're a proper European company. I think we're spread. We have, I don't know how many nations we have, probably 18 or 19 nationalities in the company. Very international. But we're based just about 200 meters from here. And we came, just a little bit about us if you don't know us, we came for a spin-off from KTH and Rice, but also from MySQL. So that's a little bit about our background. I'm going to talk about, I'm going to start by talking about sovereignty and digital sovereignty in AI. And then I'm going to talk about what Hopsworks is, right? Just many of you might have heard that before. Hopefully you won't be too bored by it. Might even do a little demo. But you know this Chinese phrase, we live in interesting times, right? But the unthinkable is now thinkable, right? So Denmark, our neighbors, they did a study recently. What would happen if at 8 o'clock in the morning you turned off AWS and Microsoft? What would happen to the country? By 10 o'clock, it would be shut down. Right? And we actually talked to people from a very large Danish company last week at the Data Innovation Summit. They're really worried about this. They're thinking, you know, if they want Greenland, they just turn off the companies. 2 hours later, Denmark's on their knees. Here you go. It is unthinkable, but it is thinkable now. I think we all understand that. I think Europe has kind of woken up to this. And we're kind of here with our pants down, right? So the Chinese, they got their clouds. The Americans, they got their clouds. They got their digital infrastructure and their digital sovereignty, and we don't. And I wouldn't say Sweden's waking up yet, but we're getting there slowly. Now, this is actually an AI picture, right? It's not the original. Olof Palme. That's color generated with AI. That's a little AI on this page. But I did a little bit of research because he talked a lot about sovereignty and what it means to be free and so on. And these quotes could be from now. He says, like, we used to look to the United States for moral leadership and authority, but look what's happening now. Small countries, their right and threat of independence is being taken away from them by the great powers. That really feels like history's repeating itself, to me at least, at some level. Now we have Saab talking here. Saab, to a large extent, I would say, exist as a military, let's call them a defense company, because of this philosophy promoted by the likes of Olof Palme, that we should be independent, technologically independent in Sweden. In order to be free as a country, we need to be able to control our destiny. And Don Emmelin, I think, had an article in Dagens Nyheter today, and he said, without digital sovereignty, there is no sovereignty. I think it's a great line. Like, if there's no digital sovereignty, you aren't sovereign. And I think, you know, if we had kind of not followed that approach promoted by earlier Swedish governments, would we really have this technological independence? And we don't have full technological independence, but military independence, I think. This is an interesting term, and I'm Irish, my native language is English, and I use the term strategic autonomy, and people look at me as if I've two heads. It's not a term you'll find in the Anglo-Saxon newspapers anywhere. If you say it in French, l'autonomie stratégique, everyone knows what you're talking about. Even the Germans talk about strategische Autonomie. Sweden, strategische Autonomie, I have no idea. I haven't seen it in newspapers anywhere. But if you look around the newspapers in Europe, you'll see they're all talking about it. Microsoft even have to now come out and say, we will protect your data no matter what. That's what they're saying, right? We know that that's not true because, you know, would they pick Denmark over their home market? I think we know the answer. But we can see also that there is actually a a financial effect of what's happening. I put Saab's share price in the corner. It's public, don't worry. We can see they've doubled in price since, funny date there, February. Somebody started working at that point in time in America. So what we're seeing is a realignment globally. And Europe is, we're in trouble, like, if we're to be honest. Ericsson, I don't know if people saw the news, Ericsson, they removed all their DEI references recently. They just got rid of it, like. And they had to deny, of course, that Trump demanded it, but of course he did, right? We know that. And if your core values, you change your core values because you don't feel you have that sovereignty, then it really hits home that if you don't have digital sovereignty, you can't be sovereign. You can't decide your own fate. You can't decide your own values. You can't decide your own future. I think in Olof Palme's time, Sweden was one of the richest countries per capita in the world. It was, an industrial country. You could go it alone. I don't think you can do it anymore. I think most people understand that. You have to pool sovereignty to go for technological independence. And there is actually a history of us doing this in Europe, right? So many people don't know about it. After World War II, Europe was laid waste, and the Americans had obviously got Boeing, and they were selling their airplanes, and it was obvious in the 50s this is going to be the next huge industry, the airline industry, because jet airplanes worked really well. So Europe actually pooled sovereignty to develop Airbus. So many people think Airbus is French, and yes, they assemble the airplanes in Toulouse to a large extent, but the engines come from Rolls-Royce and other places, and in Germany they do huge amounts of work on it. It really is a case of Europe succeeding to build a technological platform which enabled them to be somewhat independent. So where we are today is, I use an analogy from the 1800s. We're like America if we'd invited the British in to build the railroads and run the trains, and all we're allowed to do is sell coffee in the coffee bar. That's kind of where we are. But I think we're kind of, we know that we need an EU cloud, and we know that we need EU data and AI platforms. I'm going to talk about Hopsworks, which is an EU data AI platform. So that's it. That's the kind of the sovereignty aspect. I'm not going to go into too much more details. You can see I care strongly about this, and I really think we need to up our game. And I think it's clear, at least across many parts of Europe, that we will have to invest massively. And for those of you who doubt it and are cynical, I understand. But if we go back 15 years ago, when the euro was definitely going to crash, Draghi came out and said, we will do whatever it takes. And believe me, it will be enough. And he's come out again, and the new German chancellor came out again and said, we will be independent. Okay, so that's the bummer, but it's also an opportunity. And so if you're going to say we stay where we are, where's the future leading? Like if you work in the car industry and you're not making batteries, we're not doing it right now in Sweden, it's difficult. There's not that many moving parts in cars anymore. So if you're an enterprise and you're sending money to your AI service provider who uses the codependent cloud provider and the money comes back, money's going away and it's never going back to Europe. So to get our economic independence, we really need to wake up to this. All right, so Hopsworks is a European-owned AI platform. I'll make sure I don't go over time too much here. And this was not great animation. I'll blame American slideware for that. But so we have a specific philosophy for building AI systems at Hopsworks, and it's that any AI system, whether it's a batch AI system, a real-time AI system, or an LLM-powered assistant, you can decompose it into three main parts. And if you're a big team, we work with very large enterprises who build AI systems, and they build batch, real-time, and LLM-powered systems. But if the teams work together, they have a unified language and say, hey, I'm building a feature pipeline. My feature pipeline will take my data, and it will create these features and labels. And that's what we'll work on. So we've decomposed the problem into a smaller problem that we can work on independently. Training pipeline will be probably data scientists taking those features and labels and outputting a model. And an inference pipeline will take that trained model and some new input data and output predictions. And that's basically all AI systems. An AI system has data, it makes predictions. I've been teaching a course at KTH for years about building AI systems. It's actually the first ever course on deep learning in Sweden. And they have a project, and they have 1 to 2 weeks to build an AI system. And the only description of their project they have to hand in is, what is your data source? It is not allowed to be static, so no Kaggle, no like big static. It has to be a dynamic data source. What is your prediction problem? And from there, you build an AI system. And there's you can look at the web page. There's tons of interesting ones, but they do everything from financial markets to air quality to water levels to anything that's now become digitalized in society, and you can potentially use data to build a model for making predictions, you can build AI services on top of. So that's the philosophy we have, and I kind of mentioned this before, but we're an open. The other part of it is we're an open platform. So many of the kind of the let's call them the larger AI platforms, they try and lock you into their compute. You can only run compute on their platform, so you can only use their framework if it's Spark or SQL. But we're an open platform. You can run compute outside or inside the platform. So a lot of our customers run on American services, of course, and American clouds. And I will make the proviso, most of our income as a company is from the US, because that's where the early adopters are. And we're very much a kind of a cutting edge company. So if you're building an AI system in Hopsworks, you'll build these three pipelines, the feature, training, inference pipelines, and we compose them together. So often a hard part of building any sort of system that you modularize into smaller components is how do you compose them together to make the whole. And that's what you get for free with the platform. The platform has tons of services in it. I won't go into the details, but it's a Kubernetes native platform. And it's the bit that pulls all the parts together, so you get a complete AI system out of it. So you can, BYOC means bring your own compute, but you can also run your compute in Hopsworks. And if I'm writing a batch AI systems, this is for people who are interested in how do I build AI systems. Well, with Hopsworks, you can pick any technology that you think is best for your use case. So what's happened in the last 15 years is we don't just have one or two compute engines like Spark or maybe we have TensorFlow or PyTorch. We're seeing a huge number of new compute engines appearing for specialized workloads, stream processing, DuckDB for embedded SQL, Polars for a scalable version of Pandas. And data scientists and data engineers have preferences for their different tooling. So we really support as many of those as we can on the platform because we're open. But batch systems basically look like this. You get some data coming in from batch data sources, they write to the platform, you train a model with the data that's being written, and then you have a program that runs on a schedule, and it can run on a schedule in Hopsworks, and then outputs predictions. A good example would be Spotify Weekly. Once a week, you get predictions about what songs you might like, recommendations about what songs you might like. That's a classical kind of batch AI system. And a real-time AI system is one that typically has human in the loop. So often there's a human interacting with the system, and you do something and you get a response. The canonical example is TikTok. So TikTok is obviously a video platform, but kids never search. I don't even know if there's search functionality in it. When you click and swipe, it tracks your intent, and the AI that's powering its recommendation system will guide you wherever it thinks you want to go, and it's really good at tracking your intent. It's called digital crack by many people. But the technologies you have for that are slightly different. You have stream processing, you have model serving, and all of that runs in our platform, so we support all of this natively. And then if you're building a large language model applications, often we call them agents, you may have different, you mightn't train a model. Most people who do LLMs don't fine-tune models. They take off-the-shelf pre-trained models. But they'll still have to do some work. So if they're doing RAG, they'll still have to compute embeddings, and you have to have that as your feature pipeline. And then you still need to serve that model. An interesting one I saw this week was, has anyone heard of Mistral from France? It's the only European owned and trained large language model. There was another company, Aleph Alpha in Germany, were supposed to do it. They got 700 million. They stopped doing it. But Mistral got, I think, 1.5 billion. They've trained the model, and it's really good. And they're releasing a service which is, hey, I can take your model, put it in take their model, and serve it in your enterprise with ChatGPT UI. And that's kind of it's a sovereign AI service, because if you work in the government, you're probably not allowed to send your data to OpenAI. You're probably not allowed to, because they're going to keep it, or you're not going to use a Chinese service. And it's really great. But technically, if you look at a platform like Hopsworks, we have customers doing this already. You just take any open source model, you serve it, and you've got a little UI, and that's your ChatGPT. That's it. But then when you have the platform, you can do much more than that. But we can see the demand is here for LLMs, for taking even the pre-trained ones have a huge amount of value they can add in any organization today. This is a little bit technical. I won't get into too much detail because this is for the nerds out there. But why is Hopsworks different? Because many of you who are here obviously are familiar with AI platforms. Maybe some of you use AI platforms today. I say, well, what is this thing at Hopsworks? Why is it different? And I'm just going to focus on the differences. I've kind of given an overview of what you can do. You can build any AI system on our platform. But where we're best is real-time AI, GPU sharing at scale. And then I'll talk about something we do about getting teams to work together in a single cluster. And I'll do a little demo on something which is coming, which is using AI to build AI. Right? So using AI or large language models to build AI systems, which is pretty cool, I think. Right, so let's talk about real time. Now, I mentioned TikTok. TikTok, the way it's built is, there's a company, ByteDance, who built it. They have what's called an exabyte-sized iceberg lakehouse. So they've got 1,000 petabytes of data. That's a lot of data. So remember, petabyte is 1,000 terabytes. And then you've got 1,000,000 terabytes. So if you're a terabyte disk, you get 1,000,000 of those, and that's your exabyte. And they have thousands of servers running Flink, and thousands running Kafka, and thousands running Cassandra, and they've built this very impressive architecture. And it is the most valuable AI system in the planet today. It creates the most value of any AI system that I'm aware of. But the problem you have as a company is, you say, I can see TikTok's really successful. I would like to build TikTok. Or I'd like to have my application somewhat like TikTok. So I came back yesterday. I was in Zalando. So Zalando are a customer of ours. And they're building, they're only in the process of building these personalized recommendation systems now. They're Europe's largest e-commerce company. I think it's pretty cool. They're now building their AI on a European platform. So we get a lot of bad press, say, oh, Europe can't do anything, we're so screwed, we're lost. But there's no Chinese platform they can build on. And we're better than the Americans. So I think it's pretty cool. But basically, Hopsworks is designed to work on these really real-time scenarios where you get this fast feedback loop, and then it works at scale. So Zalando has 50 million or more customers. This thing needs to work at scale. We have a benchmark here where, on 168 CPUs, we can handle 1 million concurrent writes and 100,000 concurrent reads. I'm not going to go into details on it. But that's kind of, that's one of the things where we're unique globally. A lot of that legacy comes from Ericsson, actually, and MySQL. So the database that powers a lot of this, RonDB, was developed originally at Ericsson, and then MySQL took it over after the crash in 2003. And then it went to Oracle ultimately, and then it was open source, so we forked it, and the developer of the database is working at Hopsworks, Mikael Ronström. But anyway, I digress slightly. So why is real-time AI important? Well, I think if you're building an interactive application, anything that has users working on it, everybody is adding their little chatbot here. I'm calling it Le Chat, because that's what the Mistral call it. It's funny, Le Chat. But you add a little chat window, and you kind of say, hey, look, my application's intelligent. You can type in something, and it'll give you a smart answer because the LLM knows something. And you say, well, it doesn't know about my app, so you add a lot of information to your app in a vector index, and we have one in Hopsworks, so you can do RAG. Now it knows about your app, but it doesn't know what's happening in your app, right? So if I want to build a truly AI-enabled interactive application, I need to respond to your clicks. You clicked on this and this, but you never clicked on this. You want the agent to actually not be like the Microsoft clip that said, hey, you're doing this wrong. You want to be actually helpful. I say, I think you're trying to do this. Maybe you want to try and click on this instead, or give you advice in some way or other. But to do that, you have to do it with very low latency. If I click and it takes a minute for the system to react, it's not going to be perceived as being intelligent. And the other thing is applications don't just generate clicks, and you don't just have enters in text box. They do things, they have databases. So they'll have an application database, and that data also can be used to power an interactive AI-enabled application, and that's what we do at Hopsworks as well. So we'll take all this data, we'll integrate it, we'll call it working memory. It provides context and history for your AI systems, and you power it typically with IDs. Your application just sends in, hey, I need information about this user ID, this product ID, this session ID, order ID, and so on. That's where we're going, and Hopsworks is really leading the way. So another place that we're doing a lot of work at the moment with a very large Swedish company is they have hundreds of GPUs. So how do you share those GPUs across your organization? So you're buying them, it's sovereignty, right? You're not renting them in the cloud. So this is actually something the cloud giants don't typically work on, because in the cloud, you rent a GPU, you use it, and you throw it back. So you don't care about increasing utilization of the GPUs. You just use them, throw them back. It's the cloud provider's responsibility to ensure you're increasing utilization. But if you're on-prem and you've bought 100 H200 GPUs, that's setting you back 5 million euros roughly. You want to ensure that they're utilized to a high level. Otherwise, you're making a bad investment potentially. So what Hopsworks supports is is ensuring that mixed workloads, you can do inference. So often companies will maybe have LLM-powered applications that are being used during the day, and at nighttime, there's not so many users. So we can run a lot of training jobs at nighttime. But if I have a cluster, I'd also like to do scalable compute, like run things like Spark. So we support all of this in Hopsworks. It's built on an open source framework called Q. And the way it kind of works at a high level, sorry, it's a little bit technical, but you basically take your organization and say, well, I'm going to put some GPUs over to the dev organization on the left, or your right, and then on your left, I'll say I give a bunch of GPUs to the GTM organization, and they're kind of separated. You could have them all under one umbrella, but you can basically split it up if you want to. And then within the GTM org, we've got a bunch of business units here. And you can see that business unit 1 is given 4 GPUs and business unit 2 is given 2 GPUs. They're guaranteed them. And in Hopsworks, anyone who's used it here, you'll say, well, I have no idea what a business unit is. Well, we kind of, you configure this in the background, but in Hopsworks, we have a project. So everything in Hopsworks is a project. So when you're a member of a project, like a GitHub repo, you can run jobs, you can run notebooks, you can deploy models. And every time you do that, it'll request GPUs from this shared pool. It does fair sharing. There's priority for GPUs. If you're a low priority job, somebody else could take it from you. But what we can do as well then is that this business unit 1 has used its 2 GPUs, but there's a spare one over in business unit 2. So we can submit a job to a project, borrow it, and this basically helps ensure GPUs are widely utilized. And then there's a little bit more here, because if I want to do a training job and it's got a lot of GPUs, like I need 8 GPUs, I might like them to be co-located on the same host, not to be spread over the network, because then it will be I/O bound, network I/O bound. So we have support for that's called topology-aware scheduling as well. So the next thing I want to talk about that's unique to Hopsworks is what we call project-level multi-tenancy. So if you're building if you're deploying a Hopsworks cluster, every time you have a new team that you want to onboard or a new project, you don't have to deploy a new system. Because often you'll have sensitive data and you'll say, I've got this data running here. You don't have to deploy a whole new system for every team or business unit or any group of people working on sensitive data. We can run them all on the same platform. So a typical organization would be that you have maybe one project for everyone in the company. We have all departments here, and then you have different projects for different business units or teams in your organization. And then there is the ability to share data across these business units or projects if the needs require that. So the way it works if you're using Hopsworks is you'll be a member of a project. It's just like a GitHub repository, and you say, hey, Jürgen, Bob, and Alice are members of this project. They'll have access to all compute, GPUs. They'll have some quotas for GPUs. They'll be able to store their models, their data for training, their data for serving, and there's some usage tracking. But any given user can also be a member of 2 projects. So Alice here is a member of cyber and a member of narcotics. Now, what happens if Alice runs a job in cyber? Can she copy the data to narcotics? Well, the answer is no, because in every project, Alice has a project-specific identity. So the identity of the user running in the cyber project is not Alice, it's cyber_Alice. And similarly, in the narcotics project, her identity is narcotics_Alice. So in the system, when your Ray job here tries to copy data over to the other project, it'll say, don't know who that user is, CyberAlice, not going to allow you to copy the data. And this way, we basically ensure that these are sandboxes, these different projects. Within a project, you have role-based access control, because if you have a project and you're trying to, be compliant with the ever-changing EU legislation, the obvious one being GDPR. In GDPR, you have owners of data and you have processors. So we have a security model that reflects those 2 roles. So you have data scientists, they'll maybe train models, or they'll do some processing, and you can have a data owner who is responsible for membership, but also for they have privileges to update feature data or deploy models and so on. And then, of course, you can share data across these different projects in a controlled way. And actually, in the latest version, we're enabling column level access control, and then row level will come in the version after that. Right, I'm going to just show our assistant. I'll do a quick demo just so you get an idea of it. But I said that we're building AI systems by decomposing an AI system into three parts: a feature pipeline, a training pipeline, an inference pipeline. One of the things that we get when we go to, particularly to large enterprises, is like, yeah, my data scientists can write a training pipeline, but they're not very good at the feature pipeline. It's hard, right? They're like, we got the data, it's in Snowflake, and they don't know SQL, they don't know Spark, they don't want to do it. Can you make it a bit easier? And two trends we've seen in our space is point and click. Like there are a lot of tools out there where you point and you click. And this is a kind of a way of building these data processing pipelines. You say data comes from here, I want to do this, and you check the drop-down list and say, oh, that's what I want to do. And then you put the output, you put somewhere else. Obviously, compared to writing code, if you're used to writing source code, it's a much more constrained environment. The idea is that it should make you productive, though. But what we see nowadays is that I think people are more proficient in programming the likes of Python. You can put your code in a source repository. It's now an asset. You can share it. People can modify it, update it. It's flexible. You always want to do the latest, newest things, newest libraries. So the point and click thing is kind of, I would say it's under threat. And the other one that's under threat is saying, well, Python is too hard. Let's have a domain-specific language. And we'll make it even easier than Python. So what is even easier than those approaches is to use text. So why don't we use text to create these pipelines? So why don't we use an LLM or an AI to help us build our AI system? Now, as we're Hopsworks, we had to be on brand, and we called it brewer. You can also brew coffee, in case you were thinking it's just beer. And I will at this point plug that we have Hopsworks beer out there as well, if you're curious. We do actually make beer as well. And yesterday I was in Berlin, and that's where we got the name for Hopsworks. We had to the platform was called Hops, and our first talk was in a brewery, Kulturbrauerei, in Berlin. And somebody had a joke and said, let's call it Hopsworks. It sounds like a brewery. And then we ended up with that name. Anyway, so let me just show you how it works at a high level so you get a feel. And there's 20 different things that can go wrong in this as I currently stand here. But let me, so this is Hopsworks here. And it's you can interact with it like with API if you just want to work with code. But here you can see your data, where your data is coming from. Maybe I'll need to did this thing. Yeah, you can see this is what happens. I just need to port forward this thing. Okay, there we go. That worked. So I've got a bunch of data sources. So the data doesn't all have to reside in Hopsworks. I've got data on Redshift and Snowflake. It's going to access it from here. But I have tables. Some of these tables are in. So this one is in Redshift. This is in Redshift. This one is local. This one is in Snowflake. So you have these tables of data. So you can have a look at a table of data. This one's in Snowflake. You have columns of data. We have telling us where it's coming from, how it's being used with lineage. You can have things like data validation rules. You can have a quick look at the data that's in there. But what data scientists often do is they want to basically take these raw data sources and say, hey, I got to build some features. So I'm going to extract some data from it that I'm going to use as input to my model. Now you might go, what the hell is a feature? The feature you can think at a high level is a compressed representation of a large volume of data. So maybe you know what the stock market is, and you have stock prices that go like this. Well, if we talked about the 30-day moving average, that would be a feature because it's a compressed representation of the stock price over a longer period of time. You don't need as many data points to represent it. We do that a lot. Like, for example, if you're working with e-commerce, you might say, okay, I'm going to look at how many clicks you made in a period of time or the activities you've done, but I wouldn't put all of the activities in. It goes a little bit too slow for some types of models, so I can compress them into a smaller representation that has a lot of information content. So what was I going to do? Yeah, I was going to do this because I'm totally useless. I'm going to just basically say, hey, please analyze one of these tables of features, right? So I can ask my LLM. So what it can do, what LLMs are really good at is writing Python code. They're not very good at SQL. They're also very good at giving them a ton of data and saying, summarize this or analyze this. They do hallucinate. But this one I asked it, like, hey, tell me what's in this feature group called category. Now, one of the things you do as a data scientist, you'll want to see, I've got data there, tell me about it, what's in there. This may not be super interesting for many of you, but I just basically ask it to get started to do that. I can also say, and this is a really simple one, for those of you who are data scientists, please forgive me. I can say, I want to create some features from this feature group. I'm not even telling it what I'm going to create. I'm just saying, just create some. I don't care, right? So it's in this case, it's just going to go through it quickly, and it's going to look at the metadata for this table of features. So one thing that we do that's a little bit different is we have descriptions of the columns on the tables and descriptions of the tables, and extended metadata. And LLMs love all this. They eat it up to be able to reason about what type of features to create. And it basically says, hey, you know, I've done some analysis here, and I've had some insights, and I'm going to create it's going to do a profiling now. So it does some profiling. So what's happening in the background here is that it's actually creating Python code and running the Python code and analyzing the outputs, and then it's passing the output back to itself. LLMs are becoming what we call agents. So what an agent is typically is not just a single ChatGPT request, answer this question, give me an answer. They're often multi-steps. You basically want to give it some notion of a thing to do. Let's call it a task. And you say, go off and do this task, please. So here you can see it's creating Python programs. It's running the Python programs. And then it's actually, this Python program is the one to create our features. So it did some analysis first and said, I'm going to do this. And it's going to create a new binary feature called is Swedish category. And it's running now a program to create that feature group. So when we go back over here and we refresh this, we should get a feature group. It might be created at this point in time. I'm not sure if the data will be in there. Okay, so it's actually just creating the program for it. But that gives you an idea of like what, where are we going? Sweden, okay, so it created it here. So it created this code. Now, you know, what LLMs are very good at is if they make mistakes, you can basically tell it to self-correct. You know, so what we do here is we'll create a Python program, and instead of having it write directly into this table, we can mock it and say, hey, try and make sure the syntax is correct before you actually run it. And if there's a syntax problem, you feed it back in and it fixes it. So it's not like super fast at the moment. This will get faster. But it gives you an idea of kind of where we're going in the space. So that's the quick demo. It gives you an idea of what we're doing, and that's where we think we're going. It hasn't been released yet. The platform's pretty big. There's a lot of stuff. Some companies do just real-time AI. Some companies do just LLMs. Some companies use the whole thing. But really, it's a platform for doing all types of AI, batch, real-time LLMs. So if you want to find out more, we do a bit of you know, content in the community. We have a feature store community that we organize globally. We have an interesting new blueprint. I think it'll get mailed. I was told by marketing that I should tell you it'll get mailed to you. So apologies for the spam, but you're at a Sovereign AI meetup, so you're going to get mailed with this blueprint. It's a survey of over 100 professionals in the area around Sovereign AI. If you're more into for the tech, this is the first. I think it's 6 chapters are here. So if you want to take a photo of that, you'll get 6 chapters for free. I've written 13. I have 1 left to do. So the book will be finished soon. It'll be out in the summer. These things take time, but it's a journey. But it has an end as well. So that's it from me.